This is exam 1, test 1 review, business calculus, calculus for business on social science. It is additional review to your professor instructor exam test review. This is good review for students in business calculus, engineering calculus 1 and calculus 2, AP calculus, mathematics of finance. Also watch my business maths exam review, trigonometry exam review, college algebra exam review, development math exam review videos. I'm sharing this with you only as additional help in addition to your professor instructor exam test review, which should be your main essential review. This is a review of a complete review of chapter 9, limits, continuous functions and limits at infinity, rates of change and derivatives, derivative formulas, product and quotient rule, chain rule, power rule, using derivative formulas, higher order derivatives, business applications, marginals, and finance. Before we start, please subscribe, share, and like, and ask your friends to subscribe, share, and like. And thank you. My name is Osman Anwar. I have been professor of engineering and business mathematics in Dallas, Texas, USA. Please subscribe to my 4 education channels, share and like, and ask your friends to subscribe, share and like. Links are in the description. My 4 education channels are specifically for university and college students and high school students. Channel 1 is for business students. It has business calculus, business math, and mathematics of finance. Channel 2 is for engineering STEM students. It has calculus 1, calculus 2, and high school AP calculus. Eventually, I will add calculus 3, differential equation, linear algebra, and so on. My channel 3 is, it has trigonometry and high school geometry. Channel 4 has college algebra, intermediate algebra, which is a development math, and high school algebra 1 and algebra 2. In all my channels, I have 3 plans. Plan number 1 is I have exam reviews and test reviews that I have solved with my students in classroom, and my students have used those exam reviews and test reviews to excel in my class. I will convert those exam reviews and test reviews into video presentations and share them with you. Plan number 2 is I have been solving many mathematics problems, business applications, engineering applications in classroom with my students. I will convert those detailed solutions into video presentations and share them with you. Plan number 3 is I will show you how to use technology such as Excel and graphic calculators, how to use technology to solve mathematics problems, business applications, and engineering applications. Once again, please subscribe, share, and like, and ask your friends to subscribe, share, and like. Here are details of my plans. Plan number 1 is share with you video presentations of my exam reviews and test reviews. Plan number 2 is share with you video presentations of my detailed solution to examples and applications. Through my plans, you will learn how to succeed and get A in business calculus, how to succeed and get A in business math, how to succeed and get A in engineering calculus, how to succeed and get A in high school AP calculus, how to succeed and get A in trigonometry, how to succeed and get A in high school geometry, how to succeed and get A in college algebra, how to succeed and get A in intermediate algebra, which is development math, how to succeed and get A in high school algebra 1 and algebra 2. I will show you how to use technology to solve mathematics applications / problems, technologies such as Excel, graphic calculator, how to use technology to solve business math applications, engineering math applications, mathematics of finance applications, calculus derivatives and integrals, trigonometry, college algebra, intermediate algebra, development math, high school algebra 1 and algebra 2. Once again, please subscribe, share and like, and ask your friends to subscribe, share and like, and thank you very much. Number 1 is limit using graphs. So use the graph of f of x to find the following limit. So this is a graph. So limit as x approaches minus 4.5, as x approaches minus 4.5. So from the left, so walk on the line on the left. As x approaches minus 4.5, y approaches 3. So that's from the left. From the right, B is from the right. Walk on the graph on the right. As x approaches minus 4.5, y approaches minus 6. So limit from the left is 3, limit from the right is minus 6. They are not equal. That means the limit as x approaches minus 4.5, f of x does not exist. The limit from the right is not equal to the limit from the left, so the limit does not exist. Then f of minus 4.5, you stand here, you look up, you see a hole which does not exist. You see down, you see number minus 6. So f of minus 4.5 is minus 6. So the function is obviously discontinuous. You can see it is clearly from the graph there is a gap, there is a hole, so this function is discontinuous. Number 2 is limit of piecewise function. So there is a typo here, so this is not step function, this is piecewise function. Find limit of piecewise function whenever they exist. So the piecewise function is f of x equals 5x minus 1 for x less than 1, and 7 minus 2x minus x squared for x greater or equal to 1. So a limit as x approaches 1 from the left means when x is less than 1. So from the left it is f of x is 5x minus 1, that is f of 1 is 5 times 1 minus 1, f of 1 is 4. So that's from the left. From the right, limit as x approaches 1, from the right f of x, and that is when x is greater than 1. So from the right, it is this function f of x is equal to 7 minus 2x minus x squared. Then f of 1 is 7 minus 2 times 1 minus 1 squared, which is 4. Okay. Now, from the left, it is 4. From the right, it is 4. That means the limit from the right is equal to the limit from the left. That means the limit exists and it is 4. Then f of 1 is when x is equal to 1, which is this function, f of x equals 7 minus 2x minus x squared. Then f of 1 is 7 minus 2 times 1 minus 1 squared, which is 4. So this is the limit from the left equals the limit from the right, which that makes the limit exists, it is 4. And the f of 1 is 4, that means this function is continuous. There is I have made several videos how to graph piecewise function using technology TI-84+. Please watch those videos. Okay. Number 3 is use algebraic method to find the limit. So use the property of limit and the algebraic method to find the limit if they exist. So limit as x approaches 7, x squared minus 8x plus 7 over x squared minus 6x minus 7. So simply substitute 7. Then you will find out this is 0 over 0, which is indeterminate. So 0 is indeterminate, that is not the answer. So you have to do some algebra before you take the limit. And that is, you factor the numerator to x minus 1 times x minus 7. You factor the denominator to x plus 1 times x minus 7. X minus 7 cancels x minus 7, then limit as x approaches 7, x minus 1 over x plus 1, which is equal to 7 minus 1 over 7 plus 1, which is 6 over 8 equals 3 over 4. B is limit as x approaches minus 2, x to the 4 minus 4x squared over x squared plus 8x plus 12. And that is, if you substitute minus 2 into this rational function, then you will find it is 0 over 0, which is again, it is indeterminate. That means you have to do some algebra before you take the limit. That is, you factor the numerator to x squared times x plus 2 times x minus 2 over the denominator is x plus 2 times x plus 3. X plus 2 cancels x plus 2. Then this is limit as x approaches minus 2, x squared times x minus 2 over x plus 6. That is minus 2 squared times minus 2 over minus 2 plus 6, which is 4 times minus 4 over 4. 4 cancels 4, it is minus 4. Number 4 is sum, difference, product, and quotient of limits. Find the sum, difference, product, and quotient of the following limits. If limit as x approaches 3, f of x is equal to 4, and limit as x approaches 3, g of x is equal to minus 2, those are given, then a, limit as x approaches 3, 5 f of x plus 2g of x, and that is equal to limit as x approaches 3, 5 f of x plus limit as x approaches 3, 2g of x, and that is 5 limit as x approaches 3f of x plus 2 limit as x approaches 3g of x. And this limit as x approaches 3f of x is 4, it is given, so that is 5 times 4. Limit as x approaches 3g of x is minus 2, and that is 2 times minus 2, that is 20 minus 4 equals 16. B is limit as x approaches 3f of x minus 2g of x is equal to limit as x approaches 3f of x minus as x approaches 3 limit as x approaches 3 to g of x. So this is 3 limit as x approaches 3f of x minus 2 limit as x approaches 3g of x. So limit as x approaches 3f of x is 4. Limit as x approaches 3g of x is minus 2. So this is 3 times 4 minus 2, which is 12 plus 4 equals 16. C is limit as x approaches 3 to f of x times g of x, and that is equal to limit as x approaches 3f of x times limit as x approaches 3g of x, and that is 2 times 4 times minus 2, which is minus 16. D is limit as x approaches 3 16f of x over 2g of x, and that is limit as x approaches 3 8 of x f of x over g of x. The 16 divided by 2 is 8. Then this is 8 limit as x approaches f of x over limit as x approaches g of x. That is 8 times 4 over minus 2, which is minus 16. Number 5 is for the following function, find the limit at infinity, vertical and horizontal asymptote, whole, x and y-intercept. The function is f of x equals x squared plus 5x plus 6 over x squared minus 4. So factor the numerator and denominator, then it is equal to x plus 2 times x plus 3 over x plus 2 times x minus 2. X plus 2 cancels x plus 2, then this is equal to, simplifies to x plus 3 over x minus 2. A, to find the x-intercept, set the numerator equal to 0, that is x plus 3 equal to 0, that is x equals minus 3. To find the y-intercept, B, y-intercept, simply it is f of 0, which is 0 plus 3 over 0 minus 2, which is minus 3 over 2. To find the vertical asymptote, set the denominator equal to 0, which is x minus 2 equal to 0, that is x equals 2. To find the whole, it is set the eliminated term equal to 0. We eliminated x plus 2, that is x plus 2 equal to 0, then x equals minus 2. To find the horizontal asymptote, take the limit as x approaches infinity of x plus 2 over x minus 2, and that is, if you plug infinity, it is infinity over infinity, which is indeterminate. Then divide everything by the highest power, which is x, then divide x divided by x plus 3 over x, and in the denominator x over x minus 2 over x. Then this becomes limit as x approaches infinity 1 plus 3 over x over 1 minus 2 over x. And that is y equals 1 plus 3 over infinity over 1 minus 2 over infinity, which is 1 plus 0 over 1 minus 0, which is 1 over 1, y equals 1. Now graph it. To graph it, you have the x-intercept is at minus 3. the y-intercept is at minus 3 over 2. Then the vertical asymptote is at x equals 2, which is a green line. Then the hole is at x equals minus 2. You have a hole here. Then the horizontal asymptote is at x equals 1, which is a blue line. Then you have all this information, so just put the x-intercept, the y-intercept, the vertical asymptote, the horizontal asymptote, and as x approaches the vertical asymptote, the graph goes to positive infinity and negative infinity. As x approaches infinity, the graph approaches the horizontal asymptote, which is 1. And you have a hole at x equals minus 2. You have a hole. This is discontinuity here. Okay. Number 6 is business application of average rate of change revenue if the total revenue function for a blender is r of x equals 36x minus 0.01 x squared, where x is the number of units sold. What is the average rate of change in revenue, r of x, as x increases from 10 to 20 units? So the average rate of change is the same as a slope. The slope is y2 minus y1 over x2 minus x1, where y2 is rx2 minus rx1. So that's y2 minus y1 over x2 is 20, x1 is 10. So that is r of 20 minus r of 10 over 20 minus 10. So that's the average rate of change. Then simply plug 20 and 10 into the equation. So that is 3 times 20 minus 0.1 times 20 squared minus 36 times 10 minus 0.01 times 10 squared. So this is equal to 36 times 20 minus 10 minus 0.01, 20 squared minus 10 squared over 20 minus 10. And that is 36 times 10 minus 0.01, 20 squared minus 10 squared is 400 minus 100, which is 300. Over 20 minus 10, so this is 360 minus 0.01 times 300 is 3. So this is 360 minus 3 over 20 minus 10. That is 357 over 10, which is $35.7 per unit. That is the average rate of change of revenue. Okay. Number 7 is use the definition of derivative to find the derivative of f of x. So the definition of derivative is f prime of x is equal to limit as h approaches 0 f of x plus h minus f of x over h. And the function given is f of x equals x squared plus 2x plus 1. So the derivative of this is 2x plus 2, but we're going to use the definition of the derivative to find this 2x plus 2. So that is f prime of x is equal to limit as x approaches 0 f of x plus h minus f of x over h. So that is limit as x approaches 0. For the first one, for every x, we're going to replace it by x plus h. Then this is x plus h squared plus 2x plus h plus 1. minus, for the second part, is f of x as it is x squared plus 2x plus 1. So this is x squared plus 2xh plus h squared plus 2x plus 2h plus 1 minus x squared minus 2x minus 1. So the x squared minus x squared is, this cancels. Then the 1 cancels with 1. The 2x cancels the 2x. So this is equal to limit as h approaches 0, 2xh plus h squared plus 2h over h. So this is equal to limit as h approaches 0, factor out h, so this is 2x plus h plus 2 over h. So the h cancels the h, then it is limit as h approaches 0, 2x plus h plus 2. So this is 2x plus 0 plus 2, which is 2x plus 2. Number B is the slope of the tangent instantaneous rate of change at x equals 2. So this is, find, you have already the derivative f prime is 2x plus 2, then evaluated at 2, and that is the instantaneous rate of change or slope of the tangent. So that is f prime equal of x equals 2x plus 2, that is f prime at 2 is 2 times 2 plus 2, which is 4 plus 2, which is equal to 6. So that is the slope, that is the instantaneous rate of change. That's the slope of the tangent. Number 8 is derivative formulas, the power, constant, coefficient, sum, and different rule. So use these rules to find the derivative and the slope of tangent of the following. A is f of x equals 2x to the 12 minus 5x to the 6 plus 9x to the 4 plus x minus 5. Then the derivative is 2 times 12, which is 24x to the 11, minus 5 times 6 to the x to the power of 5, which is minus 30x to the power, and 9 times 4, which is 36, x to the third, plus the derivative of x is 1, the derivative of 5 is 0, so the derivative is 24x to the 4 minus 30x to the 5 plus 36x to the third plus 1. Then to find the slope of the tangent, evaluate this at minus 1, which is f of prime at minus 1 is 24 times minus 1 to the 11 minus 30 minus 1 to the 5 plus 36 minus 1 to the third plus 1, which is minus 24 plus 30 minus 36 plus 1, which is equal to minus 29. Then C is given g of x equals 3 over x to the 5 plus 2 over x to the 4 plus 6 cubic root of x. Find the derivative. First, rewrite this as g of x equals 3 to the x to the minus 5 plus 2x to the minus 4 plus 6x to the 1/3. Then the derivative is minus 15x to the minus 6 minus 8x to the minus 5 1/3, 6 times 1/3 x to the minus 2/3. Then g prime is minus 15 over x to the 6 minus 8 over x to the 5 plus 2 over cubic root of x squared. Then d is, evaluate this at minus 1, then g prime at minus 1 is a slope of the tangent, and that is minus 15 over minus 1 to the 6 minus 8 over minus 1 to the 5th plus 2 over cubic root of minus 1 squared. This is minus 15 over minus 1 to the 6 is simply minus 15. Then 8 over minus 1, minus 8 over 8 minus 1 is 8. And this is 2 cubic root of 1 minus 1 squared is 1. So this is 1, then this is 2. Then this is minus 15 plus 8 plus 2, which is minus 5. Number 9 is find the slope of the tangent line and the equation of the tangent line of the following function. So the function is h of x equals x cubed minus 5x squared plus 7, and we want to find the slope of the tangent line at the point xy equals 1, 3, and also equation of the tangent line at 1, 3. Okay. First find the derivative. The derivative of this is 3x squared minus 5 times 2x, which is minus 10x, plus the derivative of 7 is 0. So h prime of x is 3x squared minus 10x. Then find the slope of the tangent at x equals 1, which is at x equals 1, which is h prime at 1 is equal to 3 times 1 squared minus 10 times 1, which is 3 minus 10 equals minus 7. So that is slope of the tangent, it is m. Okay. Then to find the equation of the tangent line at that point, it is y equals mx plus b. That is y equals m, we know it is minus 7, minus 7x plus b. Then y is 3, x is 1, so this is 3 equals minus 7 times 1 plus b. b is equal to 3 plus 7, then b is equal to 10, then y equals minus 7x plus 10. Number 10 is horizontal line tangent, maximum and minimum of the graph. Find the coordinates of the horizontal tangent of the following function. So f of x is equal to x cubed over 3 minus 9x plus 5. So first we're going to find the derivative. The derivative is f prime of x is 3x squared over 3 minus 9x plus the derivative of 5 is 0. Then this is 3 cancels 3, that is x squared minus 9. So that's the derivative. Then find x of the horizontal tangent, and that is set the derivative equal to 0 to find the horizontal tangent. That is x squared minus 9 equal to 0. That is x squared equals 9. That is x equals plus or minus 3. So at plus or minus 3 you have a horizontal tangent. Then find the y value of x equals plus or minus 3. Then when x is equal to minus 3, then y is equal to f of 3 is 3 cubed over 3 minus 9 times 3 plus 5. That is 9 minus 27 plus 5, which is minus 30. Then f of minus 3 is minus 3 cubed over 3 minus 9 times minus 3 plus 5, which is minus 9 plus 27 plus 5, which is equal to 23. Then the coordinates of the horizontal tangent are, the horizontal tangent is at xy equals 3 minus 13, that is the first point. The other point is minus 3, 23. So this is obviously the mean and this is the max. Those are the horizontal tangent. Number 11 is business application, minimizing average cost. Suppose the total cost and the average cost functions in the dollars for a certain commodity are given by the C of x is equal to 40,500 plus 190x plus 0.2x squared. This is the total cost. Then the average cost is, it is C of x over x, which is you divide this by x, so the average cost is 40,500 over x plus 190 plus 0.2x. A finds the instantaneous rate of change of the average cost for any level of production. That means we take the derivative of the average cost. That is, if we rewrite this as 40,500 x to the minus 1, then the derivative becomes 40,500 times minus 1x to the minus 2. The derivative of 190 is 0. The derivative of 0.2x is 0.2. Then this is minus 40,500 over x squared plus 0.2. So that is the derivative. Then the derivative of the average cost. Then find the level of production where this rate of change equals 0. So you take this derivative and set it equal to 0. That is minus 40,500 over x squared plus 0.2 equals 0. That is 40,500 over x squared equals 0.2. Then x squared equals 40,500 over 0.2. That is x squared equals 202,500. Then take square root of both sides. X is equal to square root of 202,500, which is the square root of that is 450. So this is the cost. This is the level of production that will minimize the average cost. So find the minimum average cost, then simply plug this 450 into the average cost, and that is 40,500 over x plus 190 plus 0.2x, which is 40,500 over 450 plus 190 plus 0.2 times 450, and that is 370 per unit, and that is the minimum average cost. Number 12 is derivative formula. It is product and quotient rules. Use these rules to find the derivative and slope of the tangent of the following function. A, f of x is x squared plus 1 times x cubed minus 4x. So to find this is product of two functions, x squared plus 1 times x cubed minus 4, and the product rule is the first function times the second times the derivative of the second function plus the second function times the derivative of the first function. That is, f prime of x is the first function as it is x squared plus 1 times the derivative of the second function, which is 3x squared minus 4, plus the second function is x cubed minus 4x times the derivative of the first function, which is 2x. Then this is equal to 3x to the 4 minus 4x squared, 3x to the 4 minus 4x squared plus 3x squared minus 4. That is the first. The second one is 2x to the 4 minus 8x squared. If you add all this together, it is 5x to the 4 minus 9x squared minus 4. B is find the slope of the tangent of this derivative. We already found the derivative at x equals minus 2. So this is f prime of minus 2, which is 5 times minus 2 to the 4 minus 9 times minus 2 squared minus 4, which is equal to 40. B is given g of x is equal to x squared plus 1 over x plus 3. First find the derivative using quotient rule, and the quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That is g prime of x is the bottom is x plus 3 times the derivative of the top, which is 2x, minus the top is x squared plus 1 times the derivative of the bottom, which is 1, over x plus 3, the bottom squared. So this is 2x squared plus 6x minus x squared minus 1. So this is x squared over x plus 3 squared. So this is x squared plus 6x minus 1 over x plus 3 squared. So now we have the derivative evaluated at g prime at 2, evaluated at 2. And this is 2 squared plus 6 times 2 minus 1 over 2 plus 3 squared, which is 3 over 5. Then the slope of the tangent, which is m, is equal to 3 over 5. Number 13 is business application, marginal revenue. Suppose the revenue in dollars for the sales of x units of a product is given by r of x equals 60x squared plus 74x plus over 2x plus 2. So that's the revenue. Then find the marginal revenue at any level of sale, which is r prime of x. So marginal is the derivative of the revenue. Okay, so that is, this is a quotient rule. So it is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, which is the bottom is 2x plus 2 times the derivative of the top, which is 120x plus 74, minus the top, which is 6x squared plus 74x, times the derivative of the bottom, which is 2, over the bottom squared, which is 2x plus 2 all squared. Then this is 2x times 120x is 240x squared. 2x times 74 is 148x. Then 2 times 120x is 240x. Then 2 times 74 is 148. Then 60x squared times 2 is minus 120x squared. Then 74x times 2 is 148x over 2x plus 2 all squared. Then this is 240x squared minus 120x squared is 120x. Then 148x minus 148x is 0. Then 240x, then plus 148 over 2x plus 2 all squared. So that is the marginal revenue function. Then find the marginal revenue when 49 units are sold, that is r prime at 49. Then this is 120 times 49 squared plus 240 times 49 plus 148 over 2 times 49 plus 2 all squared, which gives you $30. Then the interpretation is, it is one additional unit That is, the 50th unit revenue is $30. That is one additional unit after 49. So you make 49, then one additional unit, that is the 50th unit. Its revenue is $30, and that's the interpretation. Okay. Number 14 is derivative formula, chain rule, and power rule. Use these rules to find the derivative of the following function: y equals 3 over 4 x to the 5 minus 2x cubed plus 5 to the 8. So to find the derivative of this, you don't want to multiply this 8 times by itself, which will be a huge work. Then what you do is you substitute this with u. So let u equals x to the 5 minus 2x to the third plus 5. Then y becomes 3 over 4. This is u to the 8. Then it takes step by step. First just find dy by du. dy by du is 3 over 4 times 8 u to the 7, which is 6 u to the 7. Then find du by dx. du by dx is simply 5x to the 4 minus 6x squared. The derivative of 5 is 0. So this is 5x to the 4 minus 6x squared. Then C is find dy by dx by, we know, multiplying dy by du A times du by dx, which is B. You will find dy by dx. So dy by du is 6u to the 7. du by dx is 5x to the 4 minus 6x squared. Here is, du cancels du, this is dy by dx. Then this is equal to 6, but we know u is x to the 5 minus 2x cubed plus 5, that means this is 6x to the 5 minus 2x to the third plus 5 to the 7 times 5x to the 4 minus 6x squared. Then if you factor x squared here, then this becomes 6x squared times 5x squared minus 6 times x to the 5 minus 2x cubed plus 5 to the 7. Number 15 is derivative formula, again chain rule and power rule. Use these rules to find the derivative of the following: y equals square root of 3x squared plus 4x plus 9. Again, this is not easy to take the derivative as it is. Then we're going to substitute what is inside the radical by u. Then we'll let u equals 3x squared plus 4x plus 9. Then y becomes the square root of u. That is u to the half. Then find first dy by du, which is simply 1 over 2u to the minus half, which is equal to 1 over 2 square root of u. Then find du by dx, which is 6x plus 4. Then du by dx, 6x plus 4. Then C, find dy by dx. dy by dx is dy by du A times du by dx B, which is, this du cancels du, that is dy by dx. It is equal to 1 over 2 square root of u times 6x plus 4. That is just simply A times B. Then this is 1 over 2 square root of u is 3x squared plus 4x plus 9 times 6x plus 4. So if you divide top and bottom by 2, then this is 3x plus 2 over square root of 3x squared plus 4x plus 9. And that's your derivative. Number 16 is use derivative rules in combination to find the derivative of the following function. So this is y equals 5 over 3x cubed times 4x to the 5 minus 5 to the third. So this is complex function. To find the derivative of this, we're going to apply product rule and chain rule at the same time. So the product rule, it says the first times the derivative of the second plus the second times the derivative of the first. So the first we will call 5 over 3x to the third is the first function. Then 4x to the 5 minus 5 all to the third is the second function. Then the derivative y prime is the first, which is 5 over 3x cubed, times the derivative of the second, which is 4x to the 5 minus 5 to the third, the derivative of that, plus the second, which is 4x to the 5 minus 5 to the third, times the derivative of the first one, which is 5 over 3x cubed, derivative of that. So this is 5 over 3x cubed times the derivative of this is 4x to the 5 minus 5 all squared times the derivative of the inside, which is the chain rule, and that is 20x to the 4 plus 4x to the 5 minus 5 to the third times the derivative of this is 5 over 3x squared. Then this 3 cancels this 3, then this is 5x cubed times 4x to the 5 minus 5 squared times 20x to the 4 plus 4x to the 5 minus 5 to the third times 5x squared. This 3 cancels this 3. So now we're looking at this equation. We see 5x squared here, and we see here 5x cubed. So let's break this one into 5x squared times x. Then we see here 4x to the 5 minus 5 squared and 4x to the 5 minus 5 to the third. Then we can factor out the 5x squared and the 4x minus 5 to the 5 squared. We can factor those. Then what is left here is 20x to the 5. This is 20 to x to the 4 times x, that is 20x to the 5. And here from the third, the second is out, so 1 is left, which is 4x to the 5 minus 5 is left. Then this is 5x squared times 4x to the 5 minus 5 all squared, and this is 20 plus 4 is 24x to the 5 minus 5. So this is complex function using product rule and chain rule at the same time. Number 17 is another complex function, and we're going to take the derivative of this in combination of chain rule and quotient rule. So this is y equals 2x minus 1 to the 4 over x squared plus x. Then this is equal to 4. You bring the 4 down. Then this is 2x minus 1 over x squared plus x to the third times the derivative of the inside. The derivative of the inside is a quotient rule. This is bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, which is the bottom is x squared plus x times the derivative of the top, which is 2, minus the top, which is 2x minus 1, times the derivative of the bottom, which is 2x plus 1, over the bottom squared, which is x squared plus x squared. Then this is equal to 4 times 2x minus 1 over x squared plus x to the third times, multiply this 2x squared plus 2x, multiply this 4x squared plus 2x minus 2x minus 1 over x squared plus x all squared. Then this is 4 2x minus 1. We can split this into 2x minus 1 to the third, and the bottom is x squared plus x to the third. And here it is 2x squared minus 4x squared is minus 2x squared plus 2x plus 1 over x squared plus x all squared. Then the top is 4 2x minus 1 to the third times minus 2x squared plus 2x plus 1, and the bottom is you have here x squared plus x to the third, and you have here x squared plus x to the second, and those can be combined into x squared plus x to the 5. So the whole is then equal to 4 times 2x minus 1 to the third times minus 2x squared plus 2x plus 1 over x squared plus x to the 5. Number 18 is higher order derivative. Use derivative rules to find the first, second, third, and fourth derivative of the following function. F of x equals 5x cubed minus 16x squared plus 12x plus 100. So the first derivative is 5 times 3x squared minus 16 times 2x plus 12 times 1. The derivative of 100 is 0. Then this is 15x squared minus 32x plus 12. So that's the first derivative. The second derivative is 15 times 2x minus 32 times 1. The derivative of 12 is 0. Then this is 30x minus 32x minus 32. That's the second derivative. The third derivative is 30 times 1 minus 0. The derivative of 32 is 0. Then this is the third derivative is 30. The fourth derivative is the derivative of 30 is 0. So that's the fourth derivative. Number 19 is physics application, instantaneous velocity and acceleration. A particle travels as a function of time according to the formula S of t equals 100 plus 10t plus 0.01 t cubed, where S is in meters and t is in second. Find the distance, instantaneous velocity, and the acceleration of the particle when t is equal to 2. So known facts are derivative of distance is velocity and derivative of velocity is acceleration. So A, find the distance as at t equals 2. So we have the distance formula, then this is S of 2 is 100 plus 10 times 2 plus 0.01 2 cubed. That is 100 plus 20 plus 0.08, which is 120.08 meter. Number B is find instantaneous velocity at t equals 2, which is v of 2. So that is we don't know the formula for v of t, but we know we can take the derivative of s of t to find v of t. So the derivative of s of t is 0 plus 10 plus 0.03 t squared. Then v of t is 10 plus 0.03 t squared. Then v of 2 is 10 plus 0.032 squared, which is 10 plus 0.03 times 4, which is 10 plus 0.12, which is 10.12 meter per second. C is find the instantaneous acceleration. Again, we don't have a formula for acceleration, but we know the derivative of velocity is acceleration, so we take the derivative of this velocity. The derivative of 10 is 0. The derivative of 0.03 t squared is 0.06 t. Then A2 is equal to 0.06 times 2, which is 0.12 meter per second squared. So here this is basically given the distance formula. You can find the velocity and acceleration by taking the derivative. Number 20 is business application. Marginal and derivatives is the daily cost per unit of producing a product by a company is C bar of X equals 10 plus 0.1 X dollars, and if the price on the competitive market is $70, what is the maximum daily profit the ACE company can expect on this product? First, find the total daily cost. So the total daily cost is CX is C bar of X times X, which is 10 plus 0.1 X times X, which is 10X plus 0.1 X squared. Then find the total daily revenue, and that is R of X equals P of X. That is R of X, the price is 70, that is 70X. Then find the total daily profit. The total daily profit is simply revenue minus cost. R of X minus C of X, which is 70X minus 10X plus 0.1 X squared, which is 60X minus 0.1 X squared. Then find the daily unit that gives maximum profit, and that is take the derivative of the profit and set it equal to 0. The derivative of the profit is 60 minus 0.2x, and set that equal to 0. That is 0.2x equals 60. Then x is 60 over 0.2, which is x equals 300. That is when you make and sell 300 units, then your profit is the maximum. Okay. Then to find the actual maximum profit, take this 300 and plug it into the profit function, which is 60x minus 0.1 x squared. Then this is P of x equals 60x minus 0.1 x squared. Then the maximum is 60 times 300 minus 0.1 times 300 squared. If you put this in your calculator, you will get 9,000. Or you can actually do it with other calculator. That is, if you factor out 300, then this is 60 minus 0.1 times 300, which is 300 times 60. 0.1 times 300 is 30. That is 300 times 30, which is 900. Okay. Once again, please subscribe, share, and like, and ask your friends to subscribe, share, and like, and thank you.